If you need to write numbers in prime factorization, that means you're going to need a factor tree, and you're going to need to know the meaning of exponents in many cases. Here's just a reminder of what exponents mean, and you can go back and forth on that as far as exponents go. So let's go ahead and start our 3 examples straight away by doing a factor tree on the number 35. So 35 factor tree, 5 times 7 makes 35. And that's it. I can't break down 5 and 7 anymore because they are prime, right? That's the word prime. In this case, let's go ahead and now write all prime factors from least to greatest using exponents. There's no reason to write exponents because I don't have an extra 5 or 7. 5 is already smaller than 7, so they're already naturally in order. So here is my answer. And if your math teacher doesn't like X's but they like dots, then give them a dot. That's perfectly okay as well. On the right-hand side, we have a 120. Now, there's a little bit more going on in 120, so we're going to break these individual numbers down. However you break them down in your factor tree is okay. As long as you do it correctly, it doesn't really matter how you get to your final row of numbers. Now, I don't want to confuse anything, so let's zoom in here, and let's look for the second piece. Let's look for using exponents. I see I have a number of different 2's. In fact, I have 3 of them, so I'm going to use exponents here. The next biggest number is the 3, and the third biggest number is the 5. Put my little X's, or again, if your teachers want it, put your little dots, and that is considered prime factorization. So factor trees, rewrite the numbers, done.